Good day, my name is Mafokwane Mahumole. Welcome to my online channel and welcome to today's online class. I'm an engineering lecturer at Tibet College level. I'm lecturing engineering science and for other subjects. So today's lesson or today's topic is kinematics. And then from kinematics we'll be focused on the section called resultant velocity. So under resultant velocity, we can expect about two types of problems. This is one of those types of resultant velocity problems. So maybe let's start by understanding the definition of the resultant velocity. Therefore, the resultant velocity of an airplane in a blowing wind, which is the scenario that we're going to have. We're going to have airplane in blowing wind. So that's normally airplanes do. Once they leave the ground, once they take off, they will move in the wind or air. Right. So the resultant velocity in that scenario will be the combined velocity of what? The velocity of the airplane and the velocity of the wind. So we're talking about two velocities here. So there will be moving wind or moving air, then there as well there will be the airplane moving. Therefore, we're going to have two movements. So since this aeroplane would be moving in this wind, therefore these two movements will combine and form a new movement in the new direction, meaning that once the airplane starts to experience the wind, the speed of that aeroplane will be affected and the direction of that airplane will be affected. So the speed will either be reduced or increased, and then the direction as well will be changed. So that new speed, which either will be decreased or increased, and then that new direction after hitting that wind, that new speed and new direction will be the resultant velocity. And the resultant velocity, it's a vector, it has the magnitude and the direction. Right, let's go to this video here. Let's check this video here. So in this video, we're going to have this guy who will be trying to move in that direction, and then we're going to have a wind blowing in this direction. So let's try to play this and see what's going to happen.
Okay, go. Look what's on
So this wind changed the direction of that guy. The wind changed the direction of the guy, and then instead of this guy taking this direction, this guy ended moving in that direction. So that just proves that the wind can change the direction and as well will affect the speed. So you will see that as the guy moves, his speed will be faster now. So once the guy starts to, the wind starts to come in contact with him. So the wind will push this guy in that direction. Then we'll see the guy will start moving faster. So if the wind wasn't there, this guy, he was gonna move slowly like this or at a slower rate. But because of this wind is going to change his movement in this direction, and that wind will push him like this. Then that's why now that guy, instead of moving like this, he will take this direction. And when he moves in this direction, you'll see him running a bit. So it's because this wind is going to increase his speed, and then as well is going to change his direction. So that's why when you see from this triangle, you will see maybe this one will be short. The distance from here to there will be longer, then this one will be the longest. So remember the velocity we're talking about the distance covered in maybe in 1 second. So as you can see, when this guy moves from here to there, it's going to cover more distance. But in that direction, it's going to cover less distance. In this direction, it's going to cover less distance. So that's why we say that the wind is going to increase the speed of this guy. So as you can see, this line is going to cover more distance. It's going to cover more distance compared to this distance. It's going to cover more distance in this direction. So meaning that when it moves in this direction, it's going to move faster. Right. So basically, uh, that's what is going to happen when we interact or when we get ourselves into contact with the wind. So we can also check this. So like if we are moving in the same direction with the wind, what's going to happen is that the wind is going to increase your speed. Here's the scenario here. If the airplane is moving at a certain speed in the same direction with the wind, the speed will be increased. But if the airplane is moving against the direction of the blowing wind, then the speed of the wind will be decreased. So that's why we see here, this one is going to cover lesser distance compared to this one. Now, if the airplane will be experiencing what we call the crosswind, the wind from the sides, then you'll see that the direction of that airplane now will change. Then the speed as well will be much faster. So this one is the scenario that I've just explained with that from that video. Now, from this, we can say that if this is your destination, if this is your destination, and then this is your starting point, and then there is a blowing wind in this direction. If you set your movement or your body to go in this direction, from that video, you will see that you won't reach that point. So instead of moving in that direction, this wind is going to change your direction, and then instead of going vertically up, you will end up going like this. And when you go like this, you won't reach this destination of yours. Now, in order for you to reach this destination, you will have to apply this technique. You will have to apply this technique called the creeping technique. So in this technique, you will just have to set your movement in opposite direction to that wind, to the blowing wind. So it doesn't have to be really that opposite, but you have to steer yourself, or you have to set your movement in the direction beat to that movement. So what I mean is that if you want to move in this direction, then there is a wind blowing from this direction. So in order for you to reach this your destination, if you are moving from here, you have to set your movement. Your body must try to move in this direction. Then while your body tries to move in this direction, this wind here is going to push your body, and your body, instead of moving in this red direction, it will end up going in this vertical line. So like if you want to take this direction, just remember always you have to move against bit against the direction of the wind a bit. So like this, maybe if you want to move from here to there, so if the wind is appearing from this direction, it's appearing from this direction, then we have to set your body. Doesn't have to be the boat, it can be the aeroplane or it can be the boat. So you must set your boat to this direction. So knowing that if you set your boat in this direction, then this wind or this water will push this boat or this airplane, and then this airplane will change the direction. Then that are new direction now. That new direction will be this horizontal line, which is what you wanted, which is this is your goal, your goal movement. So just be careful of that. So always just move a bit against the direction of the blowing wind so that you can get to your destination. Right. So in this question, an aircraft can fly at a velocity of 280 kilometer per hour with no wind interference. With no wind interference. It must fly to an airport which is 275 kilometers north of its current position. So in other words here, we're going to have this kind of scenario. You will have the destination here, then we'll have the aircraft here. So the aircraft wants to reach this point. It has to move straight from here to there. It has to take that north direction. So what we've seen is that if this driver or this pilot can set this uh, aircraft in this direction, and then there is a blowing wind in this direction. And what we've seen is that this thing is not going to move straight, it's going to move like this. And then it won't reach, the aircraft won't reach the desired destination. So for this thing to reach the desired destination, then we have to, the pilot must steer. The pilot must steer this airplane in this direction. So knowing that when he tries to go against the direction of this wind a bit, then this wind will change, will push, will push that aircraft, and then that aircraft, instead of moving in this direction, that aircraft will take this direction, which is the desired direction. Now, they are saying that there is a northwesterly wind. Okay, so in this scenario that I have here, the wind was blowing from, I can take this as west, this one as south. So the wind is blowing from southwest. Then take note that if the wind is blowing from southwest or west of south, it means that the wind is coming from that direction. So if that wind is coming from this direction, it means the wind is blowing in that direction. Therefore, in this question, the wind is blowing from this direction, from northwest and northwest. This is north. So northwest, we're talking about this direction. So the wind will be blowing from this direction. So if it's blowing from this direction, that wind will be moving or blowing in opposite direction. So there will be a wind coming from this direction, blowing like this. So now, if this if the pilot of this set this thing to move vertically straight, this wind is going to push it in this direction. Then this airplane will end up moving like this. So it will end up moving like this because of this wind, which is going to change the direction of this. Therefore, for this airplane to move straight, then we have to set this airplane, we have to set this airplane in this direction, against this direction. So the wind is blowing from this side. Therefore, we're going to set the aircraft to go in this direction. So this aircraft, we're going to set it, or we're going to twist it to take this direction. So the engine of this aircraft will be pushing this aircraft in that direction. But since we're going to have two forces or two things, the force from the engine and the force from the wind. So those two forces will combine and form one resultant force. That one resultant force is going to result with no movement and no direction. Therefore, as the body of this uh, airplane will be trying to go in this direction, this wind from this direction will push this body, and then this body, instead of moving in this direction of northwest, this body now will take this direction. So this body now, instead of moving like this in this direction, it will end up going vertically straight. So that vertical movement is because of that push from this wind. So that push will result with the change in direction. Instead of this direction, it will take this direction. So now, as I've indicated before, this wind is not only going to affect the direction, but it's also going to affect the speed. So when you see here this line, we can say that this movement is bit against, is against, is against the direction of the wind. So if you move against the wind, what's going to happen is that that wind is going to decrease the speed. So that's why now you'll see this line from here to there is going to be shorter. So the length of this represents the speed. So this is the actual speed, or this is the new speed after the combination of this wind speed and the combination of this aircraft trying to take that direction. So these two movements or these two forces will result with new speed, and that new speed will be represented by this line here, which is shorter now, which means the speed will be decreased. Then we can have this line here. This line here, I'm going to close this triangle. This line here is going to represent the wind. So the wind will be blowing from northwest. Then if they don't specify the angle, they just say northwest or southeast without specifying the angle, then it means that the angle of this wind will be 45. So you can just try to draw a vertical line here, and then have this, then you'll have 45. So this is 45 angle. So it doesn't have to be that, or you can draw a vertical line here. The angle from here to there will be 40, 45. So it's real up to you. It's your choice. Right. Now, the question here is 2.1. Calculate the direction in which the aircraft must fly to get to the airport. So I've already discussed that this aircraft must take this direction, and this wind will change the direction of this from this northwest direction to northerly direction. So this guy or the pilot must steer this aircraft to this direction. So the aircraft must take this direction. Okay, good. So we can see the direction that we must take now. It's between. It's going to be between. It's going to be between north and west. Yes, we can see the direction is northwest, but we need to be specific because this direction is still northwest, here is still northwest, here is still northwest. So to be specific, we have to find the angle. So we have to find the angle. So now I'm going to save time. I'm not going to do press calculate and blah blah blah. I will just show the worked calculations. Right. What we know so far is that this angle here is going to be 45. And then as well, if you draw a line like this, a horizontal line. Let me say horizontal line like this. Use a vertical line. You are going to have 90 degrees here. You are going to have 90 degrees here. And then if this is 90 degrees, so if this angle is 45 here, this angle here as well would be 45. So this angle that I'm talking about here is this one from here to there. So that angle is 45. Therefore, since this line is horizontal, this one is vertical as well here, the angle is going to be 90 degrees. So now this total angle, this angle starting from here to there, this angle is going to be how much? This angle is going to be 90 plus 45, which is 185 degrees. So get this blue angle. Right. Now at least we know we know this angle now. What we're looking for, remember, we're looking for this angle. The direction as I've said is northwest. So, but now we have to find this angle. We have to be specific. So to find this angle here, we're going to use this. We're going to have, maybe let me quickly draw that thing here. From that triangle, we have this. We're going to have this. And then we're going to have this. So now this one represents the wind. That wind is blowing with the speed of 72. We said now we know this angle here. This angle is 135, as I've explained it before. You are going to have 135 degrees. Going to have 135 degrees there. So actually now we're looking for this angle here. Now, so we're given this the speed of the aircraft. So from the question, they give us this speed of 280. The aircraft can fly at the velocity of 280 kilometers per hour with no wind resistance. So if there wasn't the wind resistance, if this wind wasn't there, this thing, it was gonna take this direction with peace, without disturbance. It was gonna go in that. So it was gonna take this direction with the speed of 280. But now that is not going to happen. This will only happen only if there is no wind blowing. Then this aircraft can go in this direction with this speed. So once the wind starts to hit this, then this wind is going to change the direction of this, and then it's also going to affect this speed. So the speed now will be affected. So that speed will change now. That speed will change from this speed to this speed here. So we still have to find the new speed, which is going to be the resultant speed. Let me show you this. Let me show you this. Yeah, let us check this thing here. This thing you can check it at the moment it's moving straight. You will see it. It's moving straight, moving straight, moving straight. It's not yet moving in the air. So our frame of reference is when this thing starts to move in the air. Now we can see still in contact with the ground. So once it starts to move in the air, look what's happening. The wind is blowing in this direction as they are showing you there. So the wind is blowing this direction. This thing was trying to move straight like this. Then because of this wind, this thing ended up taking this direction.
That the velocity in the x direction throughout this whole trajectory, if there is no air drag, if there is no friction, is not changing. It's only the velocity in the y direction that is changing. That the velocity in the x direction.
I want you to observe something. So once this thing starts to lift, you will see now the speed will be affected. This thing will start to move slowly. So you will see now at the moment, initially this thing will be moving faster. Then once it starts to move into air, it will start, the speed will decrease. Check the speed now, it's quite faster. Then once it starts to lift, the speed decreases, and then the angle as well changed, the direction of the movement as well changed. So that is the scenario that we're going to have here. Exactly, more or less exactly the same thing. The wind will be blowing in this direction. The wind will be blowing in this direction.
That the velocity in the x direction throughout this whole trajectory, if there is no air drag, if there is no friction, is not changing.
Managed to change managed to change that direction and also affected the speed, decreased that speed. So as I've said, that this line here is going to represent that speed. And that speed is the speed that we are going to call it resultant speed, or is the speed that we are going to call it the actual speed, or we're going to call it the speed relative to the ground. Now, when we look here, we're going to use the sine rule to solve this. From sine rule, we're going to say sine theta sine theta. Here's the theta divided by the opposite side, which is 72, equals to sine 35, which is this one, divided by the opposite side is 280. From there, you make theta the subject of the formula, you will find that theta equals to this. Now, it means that now we know the angle. Remember, we got the direction before, but we wanted to find a specific direction, the angle. So the direction we can see here, this direction is northwest. So we're going to say the direction of this is going to be, look here, this angle, you will start to measure it from here, from this line which is north, then you will measure it towards going in this direction, west. So we're going to start at north. Here is it. You'll start here north. Then we'll measure the angle of 10.47, which is this one here. I left that 0.47. You move from north with that angle of 10.7 towards west. So that's how we're going to write the direction. So alternatively, if you don't want to express this direction in that way, you can find this angle here. You can simply draw the horizontal line from here. If you want your reference to be horizontal line, still fine. You can draw horizontal line here and then measure from this to there. So this one, it will be west. So you will be measuring from west towards north, going up. Therefore, this angle, let's call it maybe beta. So this angle beta will be equals to, remember, angle beta plus theta, it will be equals to 90. This angle plus this angle equals to 90. Therefore, beta will be equals to 90 minus theta, which is 10.476. 476. Therefore, when you subtract there, you will end up having the angle of how much is it? Yeah, let me quickly get the calculator. I didn't calculate this angle here. Let me see if I can get my calculator here. Here we go. I'm going to have 90 minus 10.476 equals to 79.54. 79.524. Okay, 79.524. Yeah, so if you want to measure from west, then we're going to have this one is wrong. We're going to have west. You start from west, you measure angle of 79.5 towards north, going up. You measure from here, going up. If we're measuring from here, going down, it was going to be south. So now, because we measure from here, going up, then we're going to have north. So this is 79. So yeah, you will have two options for the direction. It's either north 10.47 west or west 79.5. Right, that is the answer for the direction. but someone might like to take alternatively. You can calculate this direction by using the component method. So is this one here. So we are going to resolve these two into components, this one and this one into components. So when you resolve this thing to components, you'll have the component of the wind, the horizontal component like that. Then you'll have another component like that for the wind. And then for this aircraft as well is going to have the component, sorry, it's going to have the component in this direction, and then the component in that direction. So you can see that this one and this one, they're acting in opposite direction. Right. Since this aircraft is going to move to the north, so it's not going to move sideways. So as I wrote here, it's not going to move to the east or it's not going to move to the west. It's strictly going to move up. So at the end of the day, this thing is going to move up. It's not going to take this direction. This direction is not, this movement is not going to be there. It was going to be there only if there was no wind resistance. Right, because of that, then we can say that this component will be equals to this component here. This component to this side will be equals to this component. Then this component, we're going to call it, this is still 45. You can call it 72 cos 45. So is this one 72 cos 45 will be equals to this component here. This component here, remember at the stage, we don't know the angle, we don't know the direction. We just know the general direction that if you want to move to the north, you must take this direction. So we just know you must take this direction, but we don't know at what angle. So these angles B and theta, we don't know them at this stage. So now if you don't know this angle B, then you will say that this component is going to be, okay, I can see from my solution I've used a theta, but let me use both of them, it doesn't really matter. So if you use the angle B, then we're going to say that this 280 cos beta, this will be the component. Or if you use theta, then we're going to say 280 sine theta. So it's either you use this one or this one, it doesn't matter. They are the same. Right, I can see from my solution I've used this. Then we're going to say this component equals to that component. Since this thing would be moving strictly vertical, there won't be movement to the sides. Then movement to the side means that it will be balanced. So that's why this component will be equals to this component. So this component here is going to be this one. So you equate them. After equating them, you will see that you will only have one unknown, which is theta. From there, you will just do the mathematics. Then you will get this angle. So if you decide to say this component equals to that, then you will have 280 cos theta equals to this, equals to 72 cos 45. Then in this way, sorry, it must be cos beta here, 280 cos beta. So if you want to use this, you will say this 280 cos beta equals to 72 cos 45. Then the angle that you will get here, you must get this 79.5. 79.5 degrees. Good. Therefore, from here, while I still have my components here, let's go to the second question. Calculate the resultant velocity calculate the resultant velocity or velocity relative to the ground or actual velocity. So that is one thing. So we're talking about this new velocity, which will be from the combination of that movement of the craft like this, aircraft trying to move like this, and then the movement of that wind blowing from that direction. So those two movements will combine and form a new movement, which is going to be this one. So now we'll be looking for the speed, which is going to be that new speed, that decreased speed. So we'll be looking for the speed of this. So now how to get the speed? We can use the same thing. We can use sine rule again. We have enough information to use sine rule. From sine rule, you can say sine 135 equals to the opposite side, which is 280, which is this, which is going to be this part, equals to sine this angle. Remember the stage now, we know this angle. We know this angle. What's going to happen is fine. Let us not use this. Let us not use this, is because we're looking for this. We're looking for this. This is the side that we're looking for. So if you use this angle, you will be trying to get this side, but already we know this side. So let's use this angle here. So let's find this angle. Let me say this angle. Let's say it's C. Let's say it's angle C. So to find angle C, you are going to say angle C will be sum of angles of triangles. So we're going to say angle C will be equals to 180 minus 135 minus 10.47. Then you will get that 84 point something. So you'll say 180, which is the sum of angles in a triangle, minus this angle, minus this angle, minus this angle, then you'll get angle C. So you'll say this angle C divided by the opposite, which is what we're looking for. We're going to call it VR, resultant velocity. So this side we're going to call it the resultant velocity. Therefore, you'll say this angle C, which is 34, divided by the opposite side, which is VR. From there, you make VR the subject of the formula, then your final answer will be this. So yes, if you want to use as well the components, okay, maybe before that, you can still get this thing using the cosine rule. Cosine rule, we just need included angle and the two sides. So like here, to get this side here, you will have to use this opposite angle and the included side, the sides that forms this opposite angle. So now if you are looking for VR using cosine rule, VR will be equals to this side, which is 72 squared, plus this side here, which is 280 minus 2 multiplied by those the product of those two sides, cos of the included angle. So these two sides, they form this angle C, which is 34. Then after that, you put the square root of that, then you'll still get that. So that is the alternative angle. Alternatively as well, you can use the component as well. So you can use this vertical component, this one, and that other vertical component of this line. So the vertical component of this line now is going to be, if you use a theta, this side, if you consider this angle theta, then this component, this vertical component, is going to be 280 cos theta. Then if you consider this one as well, this one is going to be 72. This component here 72. If you consider this angle, which is 45 here, if you consider this angle, then we're going to have sine 45. So as you can see, one is going up, one is going down. So that's why we're going to subtract them. Then this time, there is upward movement. So upward, the sum of this vertical component is not going to be 0. There will be a vertical speed. So this time, the sum of this thing won't give us 0. So the sum of these vertical components, they're going to give us the resultant velocity. So which is the upward one, you will make the upward one positive, which is this one, and then the downward one, you will make it minus. And remember, we calculated the angle theta, that you will replace the angle theta by 10.47. Then you will get the same answer as the previous one. So that answer will be this. Now, the next question, it says calculate the time the flight will take. So in other words, they are looking for the time from this starting point to this end point. So how long will it take this thing from here to there? So we're going to use the formula that we know, which is going to be S equals to VT. So from the question statement, they gave us this distance. So 275 kilometers. So they say it must fly to an airport 275 kilometers north of its current position. So the current position is this one. Then from the current position to the destination, the distance is going to be from here to there. Distance is 270. So we're going to have 275. What's going on? Okay. This is the distance from here to there. So now, since we know the distance from here to there, which is 275. Then we also know the vertical speed or the actual speed from here to there is that 224. So we know the distance, we know the speed, we can find the time. So time will be equals to S over V. So you will just take here's the formula. Just take that distance divided by that actual velocity or that vertical speed. So if you use the vertical distance, you must also use the vertical speed. So if you want to use the vertical, this speed in this direction, which is that speed of the wind, that speed of 72. If you want to use that speed to get the time, it's still fine, but you must get the distance in this direction. You must get get the distance from here to there. So if you want to use that 72 here, you must also use, well, that 72 is the speed, not the distance. If you want to use 72 here, no problem, but you must also use the distance in that direction. So when I'm saying the distance in that direction, I mean you must find the distance from here to there. So to find the distance from here to there is not the big issue. You can remember, you know the angle here. The angle is 10.47 degrees. So if you know this angle, remember you know this distance on this side from here to there is 275. You know the distance from here to there, the vertical distance is 275. So that distance, in other words, is the distance from here to there. From here to there is 275. So you can still use sine rule to find the distance from here to there. I'm going to call it the W. Let me just call that distance W. So you will see this angle here. We are going to say the sine of this angle, which is this part, divided by the opposite side to get W, equals to this angle. This angle doesn't change. It's that angle C, which we got as 34. We're going to say this angle 34, which is this one, divided by the opposite distance, or the opposite side, which is from here to there. So the opposite distance is 275, is this one. Then from there you get W, but remember this W now is going to be the distance, since you've used the distance here. Then you're going to get the distance there as well. So the distance from here to there is going to be this much. Then back to this, remember this is an alternative. This is alternative. So that is when, if you want to use this component, you must use the speed of this component and the distance of this component. So now we got the speed is 72, we got the distance of that component is 88, and if you want to find the time, you will take that distance, which is 88, divided by this velocity, which is 72. You will still get the same time. So time is the same. So yeah, remember this time as well. Okay, to get it as well, to get the time as well, you can also use this. You can use this distance from here to there. Then you can still use the speed. That speed from here to there, we already have the speed. From here to there is 280. So you can use 280, but you must find the distance from here to there. So that distance you will get it by using the sine rule, the same way we did with this one. Right, so to convert this thing of time into minutes and seconds, you can use your calculator. You can say, you can use any, you can say 88.224 divided by 72 equals to, you can come here, yeah, you can come to this button there, it's gone. You can come to this button that shows about 3 quotation marks. Then you can see you'll have 1 hour, 13 minutes, and 31.2 seconds, which is this one. Yeah, thank you very much for your time. That's the end of this lesson. But maybe let me just touch another problem quickly. Just the summary. It will just be the summary. I mean, I'll just summarize it. There is this other video that I wanted to show. Yeah, even though that this one is not clear, but yeah, what's happening here is that there is a wind. Yeah, yeah, there is a wind blowing like this, and then this thing is trying to land. So for this thing to land straight like this thing must be tilted in that direction. Then as it's tilted in that direction, the wind will change that movement, which is this kind of movement, to this. So that, which is more or less the same thing as that problem that we did, but this thing is the top view. It might not be clear for you because here we're seeing the front view. So if you look at this thing from the top, that's what is going to happen. This thing will be pushing in that way, and then the wind will be pushing in that way. And when you look at from the top, this thing will move straight like that. Okay, lastly, there is this problem that I just want to touch it. I see none here, but let me go to this. Yeah, good. So if you check from this, Uh, this pilot wants to take this direction, north 33 west. This is north, this is west. So this guy wants to take this one to go in that direction. So at an angle of 33. So now for this pilot with his jet to take this direction. Remember, if this pilot said this thing to take this direction, the wind will push him and the jet. Then instead of taking this direction, they will end up moving in that direction. So for these guys to move in this direction of north 33 west, they must move against the direction of the wind. So now the direction of the wind plays important role. It will depend. So for in case if the wind blows from this direction, then the pilot must take this direction. Then this wind will bring the movement to this movement. Will change that movement to this movement. So now if the wind blows from this direction, then the pilot must make sure that he steers that boat to take this direction, knowing that this wind is going to push this thing upward, then it will end up moving in that direction, in the direction of the blue line. So now let's get where is this wind coming from. So this wind is from southwest. So if the wind is from southwest, yeah, the wind southwesterly. The wind southwesterly means the wind is from southwest. So this is south, this is west. So the wind is coming from this direction. So if the angle is not given between south and west, then we take the angle as 45. Then the pilot must take this direction of this black line. Then if we take the direction of that black line, as a result, the movement of the jet will end up being this direction, which is the desired direction. Remember, at the end of the day, this thing must move in that direction. So that will be the desired direction. So now you will just have to maybe close the triangle. And you will just have to close the triangle, then find the resulting velocity. So if you close the triangle, you will have the wind of this gas of the wind, which is going to be this. Then your triangle will be this one. Your triangle will be this. So this will be the resulting velocity or the resultant velocity. So 2.1.1, that's what you have to find. That's what you have to find. So the flight direction, in order for the pilot to go that direction and north 33 west, it will be this direction. It will either you measure it from here to there or from here to there. So 2.1.2 is looking for this angle. It's looking for that angle. So for the sake of time, I'm not going to solve it. It's more or less the same with that the previous angle, the previous problem. So it will just be a matter of using the sine rule and so forth. Sine rule. Remember, you know this side is 87. Right. Thank you very much. Thank you for your time. See you in the next lesson. Bye bye.